Assalamualaikum girls, hope that you are fine and in good health. Isa told me that about the problems you are facing while doing sections 5.5 and 5.6. Let's discuss these sections a bit so that you could do your problems easily. In section 5.5, the major algorithm is Runge-Kutta Fehlberg method that you can briefly call it as RKF method. RKF method. In RKF method, we have to approximate the solution of the initial value problem y prime equal to f of ty, where t lies between a and b, and initial condition is y of a equal to alpha. The endpoints input values are endpoints a, b, the initial condition alpha, tolerance, and maximum step size and minimum step size. Here we are given two step size values, h maximum and h minimum, and we have certain reservations about choosing an appropriate step size out of these two values. In this method, we have an additional thing that we have to approximate the step size in each iteration too. Therefore, our output values are t, w, and h, where w approximates y of t and the step size h was used, or that will be used to compute the iterations. The step size h can be used to update it using the formula that is obtained from step 8 of the algorithm, and you can use step 8 of the algorithm in which you will compute delta to approximate an appropriate value of h for the next iterations. If delta is less than equal to 0.1, then we will have h equal to 0.1 times h. Here h is the previous value, so you will multiply previous h by 0.1 to obtain the new h. Else, if delta is greater than equal to 4, then h will be equal to 4 times h. And else, if delta is greater than 0.1 and less than equal to and less than 4, then h will be equal to delta times h. With this computation of h, we will proceed further to complete the method. In example 1, we have started with maximum value h maximum, that is equal to 0.25, and then using this value of h, we have computed k1, k2, k3, k4, k5, and k6. Using these values of ks, we approximated two approximate solutions, w1 till d using 5-point method, using a method of order 5, and w1 using method of order 4. The value of k is equal to 0.0000062138, or you can say that it is equal to 6.21388 multiplied by 10 raised to power minus 6. With these computations of ks and r, we can approximate delta of algorithm that is represented by q over here. That is delta that was equal to 0.4 times tolerance, fourth root of tolerance divided by r. Over here, tolerance is equal to epsilon, that is equal to 10 raised to power minus 5. R is equal to 6.21388 multiplied by 10 raised to power minus 6, and so q, that is actually delta of the algorithm, is equal to that is actually delta of the algorithm is equal to 0.946161033291. Now, since q is smaller than 1 and so according to the algorithm, q is greater than 0.1 and smaller than 4. So an appropriate choice of new value of h is equal to delta times h. So using delta times h, we have h equal to q times h, that will be approximately equal to 0.2365258. That was I think now it will be clear to you, and you can proceed with this new value of h to